Hi, I'm Ms. Hall, and this is Lesson 80, Geometric Areas and Experimental Probability. Some probabilities are found by calculating a ratio of two lengths, areas, or volumes. Such probabilities are called geometric probabilities. Example 4. You throw a dart at the board shown. Your dart is equally likely to hit any point inside the square board. Are you more likely to get 10 points or 0 points? So we want to find the probability of 10 and the probability of 0 points. So the probability of getting a 10 is the area where we could get 10 points over the entire area. Area where we could get 10 points is this inner circle with a radius of 3. And the area of a circle, if you've forgotten, is pi r squared. So area of 10 points, the radius is 3, so this is pi 3 squared over. The entire area is the square. Area of a square is side squared. The entire side, if this radius is 9, the big circle, entire side is 18, so this will be over 18 squared. And then we can just work on simplifying this. So we get 9 pi over 324. You could leave it like that. Or you could divide it and get 0.087. And writing that as a percent is 8.7%. Okay, so the chance of hitting the 10 is 8.7%. Now we're going to compare that to the chance of your dart landing on the 0 part. Now the 0 part are these outer corners. So we're going to find the area of the 0 point, or 0 points, and then the entire area. We already know the entire area, but to get the area of those outer corners, we're going to need to take the entire area of the square, which is 18 squared, and subtract out the large circle. And what we'll be left with is the area of the corners. So that large circle has a radius of 9, so this is pi 9 squared over 324. I already calculated the entire area before, it was 18 squared. And now I can rewrite this as 324 minus 81 pi all over 324, which is 0.21 or 21%. Okay, so now I found the probability of the dart landing in 0 versus the dart landing in 10. And I'm supposed to, are you more likely to get 10 points or 0 points? You are more likely to get 0 points. So the probability of landing in a 0 spot is greater than the probability of landing in a 10. So the first topic of this lesson is geometric probabilities, and the second topic is experimental probabilities. An experimental probability is based on repeated trials of a probability experiment. The number of trials is the number of times the probability experiment is performed. Each trial in which a favorable outcome occurs is called a success. The experimental probability can be found using the following. Experimental probability equals the number of successes over the number of trials. Example 5. Each section of the spinner shown has the same area. The spinner was spun 20 times. The table shows the results. For which color is the experimental probability of stopping on the color the same as the theoretical probability? The theoretical probability for landing on any one color is 1/4. And we will compare that to the experimental probabilities based on the table. The probability The experimental probability of landing in red was the number of times the spinner landed in red during the experiment over the total number of times, 20. The probability of green, the experimental probability of green is 9 out of 20. Experimental probability of blue, 3 out of 20. Experimental probability of yellow is 3 out of 20. See if we can reduce any of these fractions. Yes, this reduces to 1/4. You can see that's the same as the theoretical probability of landing on red. So I can answer this question by saying the experimental probability and the theoretical probability of landing on red are the same.